Hi there. Looking at topic 2 science, here's a question. Looking at a factory with administrative staff. So a little office in there. There's heat losses through the external wall, so we're assuming the materials of the wall are probably not standardized or good enough for somebody to be sitting and trying to be comfortable in a sedentary space. Factories are normally big open warehouses, so they've probably got different places. It's not a warehouse, but yeah, get the idea. So the idea is we've got an external wall, we've got the dimensions, we've also got a window. We've got the U value of the wall and we've got the U value of the window. We need to know the total heat losses through the external wall if the internal temperature is this and the internal temperature is that, 22 and -2. 4 marks to find out total heat loss. So what's the first thing we need to do? Well, we need to think, can we calculate external wall data? Okay, this is what we've been asked to do. We want to make sure we can get the total heat loss. So how about calculating the area of the external wall and then maybe the area of the window? If you take the area of the window from the external wall, you get not only the total external wall by itself, but you've taken away that window area, so it is just what that material is about. Because if you look here, there's 2 different U values, the wall and the window, so you do need to separate them out. It's watts per metre squared Kelvin. So when we're trying to work out our heat loss, we're trying to just find out what the watts are. So what do we need to do? We need to get rid of this, the metre squared Kelvin. Metre squared is area. So as long as we find the area of these 2 items, that's halfway there. And then the Kelvin is the actual temperature. So we've got temperature information here, so we can work it out. Do not forget, you're not expected to remember the formula. There's a formula chart in the back of all exam papers. If you're in industry, you'd have your formula maybe on your desk, or you'd have like a access. You can Google it now these days, really. Or you go to your CIBSE mag and you've got your Chartered Institute information that gives you all these calculations. So here is the calculation. UA delta T. If you're not sure what all that means, please go back to your notes and go back to looking this up and having a little go at heat losses online or whatever. U for U value, A for area, and delta T is the difference in temperature. If you times all those together, what you will find is that watts per metre squared Kelvin ends up being multiplied by metre squared Kelvin. Top and bottom cancel themselves